is just terminology stuff for you. A recursive rule just links a sequence to a previous term. What's a really well-known recursive sequence that you've learnt about in the past, where a later on term is determined by the previous ones? Begins with an F.
Fibonacci.
Fibonacci. How's Fibonacci sequence formed?
One plus.
Remember?
One plus 2.
So it's actually the two previous numbers, isn't it? So you've got your first number is 1, and then your second number is 1. Well, yeah, is 1 again. And then the next one is 2, because 1 plus 1 was 2, and then the next one is 3, because 1 plus 2, and so on and so on. So it's always the two previous. So that sequence is a recursive sequence because it relies on the two previous terms. Now, there's different ways of writing it. So these are just talking about the one previous term, but it could be two previous terms. So recursive sequences, for example, could be that if you knew that each term was 4 more than the previous, you could say that un plus 1 would be equal to un plus 4. Okay? So let's just have a think about that. So the first term we would have to be told, but then the second term would be n plus 1, yes?
Okay.
Which would be the first term plus 4. Does that make sense?
Okay, yes.
If we wanted to know the third term, for example, then we would need to know the second term plus 4. If we wanted to know the 15th term, we would need to know the 14th term plus 4. Yeah?
Okay.
So this is one way. Oh, darn it. This is another way of saying exactly the same thing. So notice these are n here and n plus 1 here. But this is n minus 1 here and n here. They both mean the same thing. It's the previous term to it. Does that make sense? So just some people get freaked out when they see n plus 1 and n, and then they start seeing n minus 1 and go, oh my god, I don't know what's going on. It means the same thing. It's just written in a slightly different way. Both are completely accurate. Both mean the same thing. Okay?
So now that you said you were trying to find the 15th term, W 14.
Yes.
Great. So is the n 13? So it's 3 plus.
So if we wanted to know U15,
right,
that means that it must. I need to know. So that represents n plus 1.
Right.
So that means that n would have to be 14. Yeah?
So then I put n minus 1.
So same kind of thing. So if we were trying to find U15,
right,
then this means that this would be U14. Okay, both, as I say, both of them mean the same thing. They're just written slightly differently. Okay?
Yeah.
So for any of them though, you would need to be told some terms. But it's a bit of a pain in the bottom because it always relates to the term before it. So if you wanted to know term 25, you would have to work out term 1, 2, 3, 4, all the way up to 25 in order to get that information. Okay? So recursive sequences aren't used as often because they're a bit of a pain to deal with. This again is another one. It's not just 4 more, it's 5 times it. Okay, so we would just multiply the previous term by 5. Same kind of principle. And so deductive is what we're used to. So the deductive sequences are where it's related to the position in the sequence. So we're looking at, if we want the 25th term, we literally would substitute the value of 25 in place of the n, and we get to know the term straight away. Okay, so that's what we normally are looking at. I didn't even write some examples because I just had so many of them in the past. So if we were to write the first 5 terms of the following sequence, here's my rule. If I need to know the first 5 terms, well, they've helped us out. They've told us U1. That's 1. So what would U2 be? How would I find U2? Other than going on Spotify. No, you maybe do that. Oh my god, I'm so not.
You don't care?
Yes, I am.
Oh, it just disappeared.
Yeah.
Okay. Oh no, that means you've also got a man for joke.
Okay, so you two, how do you two?
One. Yes.
Yeah.
One.
No.
Okay, so let's have a look. Our rule, so this is our new rule. This says that u n plus 1 is 9 lots of un subtract 10. So if I wanted u2, that indicates that this is u1.
Yeah.
So that's going to be 9 lots of 1 subtract 10.
Oh, got you. Got you.
Okay.
Yeah.
So that's negative 1. Okay. Oh, we're not going to have a lot of space, are we? Right, tiny. So u3, how am I going to find u3?
So it's going to be 9 lots of 2, right?
Of u2.
U2.
What was u2?
Minus 1.
Yeah.
Minus 10.
Yeah.
So that's minus 9 minus 10.
Which
Which
is?
is
You got your other way, so 1, right?
No. Mine's
19. Minus 19.
Alright, wait, I heard a lot. Hang on, let's pause.
It is
Alright, so what are our next numbers? Oh, God, we'll do 4 and 5. Oh. So u4
Is
9 lots of negative 19 subtract 10.
which is minus 181.
I'm believing you. Right, and
I got
u5
Is minus 1639.
1639.
Yes.
Okay, trust me, Anne. Alright, next one.
N equals 4.
Now, what kind of sequence is the second one?
Geometric, arithmetic.
Using the words that we've used here. So is it recursive or deductive?
Oh.
Is that the doctor?
Deductive. This one's deductive because it just depends on n.
Oh.
So this one was recursive because it used the previous term or another term in the sequence. The term or terms before it. But this one just relates to the value of n. So u1 is simply 5 multiplied by 1 squared, which is 5. u2 is just 5 multiplied by 2 squared, which is?
That's 4 times 5 is 10.
Yes. u3 is 5 multiplied by 3 squared.
And that is 3 times 2 is 9, 9 5 is 45.
Wow, child, you're doing it.
Good mental maths, ace girl. And 5 multiplied by 4 squared.
9 got me. 16 times 5 is
16 times 5?
not 100.
I don't know. What's 10 times 5?
It's 80. Yeah, sorry.
Well, 10 times 5 is 50 and 6 times 5 is 30. You add them together. And u5 is 5 multiplied by 5 squared. 5 squared is
100 times. I mean,
25
times 5 is 125.
okay, check you all out. I'm so impressed.
I understand.
Just bruh. I would start moving at the one, but
Okay, oh, inductive is another way of saying deduct. No, recursive. Okay?
Inductive is recursive.
Yes. No. Yeah, yes.
Are you sure?
Yep. Okay, so there's lots of different ways, so I'm going to let you think of one. Because we're... Okay, so we've got those as examples. Right.